Hello, folks. Yeah, as I mentioned the other day, last week in class, we are not going to be meeting this week in person because I'll be away for my conference as I announced to you. So I'm posting this video. Please go through that so you'll be able to go through the week assignment that we have every week. All right. So saying that, today's discussion is going to be based on our grounding and bonding system. This is in relation to electrical wiring system. Before we proceed, I'll take you back to where we ended last week. We went through discussion on low voltage electrical systems, and then we cover topics such as conductor types, voltage distribution, and installation procedure, while the emphasis or the importance was on code compliance and proper communication when it comes to coordinating the team to be able to install your electrical system to the end user, right? We went through other aspect, which is electrical wiring, including material type, what role does the materials play, and how do you select those types of materials. We talked about installation type. How do you install these systems so that it's safe enough for the end user, which is our consumers. And then we highlighted on significance of selecting appropriate wire sizes based on your construction project requirement. These are very important things that you need to consider when you're dealing with it. And we concluded with discussion of the cable types, raceway sizing, and then how important is it to select a proper raceway to provide a pathway or channel for those wires that are selected for the project. And this is in line or trace to meeting the code requirement and your specification when it comes to installation. So that's where we ended last week, our last meeting. This week, we are bringing one important concept, which is the grounding and bonding system, the role it plays in the entire electrical wiring system for our inside low voltage installation, right? All right. So going forward, we talked about the bonding system. Why is it important? And then how is the system installed properly so that it gives the user exactly what is required for them to be safe and work within use those services, right? So you look at my slides here. I add my question is why is it done? I'm referring to the bonding and the grounding system. And then how is the system installed properly so that it perform its required functions, all right? Let's take an example. For instance, at your home electrical service equipment, it is very critical component of your home electrical wiring system. Why is it that critical, right? It doesn't only give you the size properly, but it also able to direct you on how these installations are done, right? Let's talk about all circuit and feeders you have at your home, right? You need to protect it from damage in terms of shock, and if there's any tremors, how will your system will still work safely for you, right? So the bonding and the grounding system are kind of part of your entire installation. And what it does is that it safeguard the you guys, the occupants or the users in the home, right? So again, looking at how installation is done, you will look at your National Electrical Code, which is your NFPA 70, which by now you have the copy as we went through the other day. So the code compliant is very necessary, right? As we looked at it earlier on, we talked about the circuit breakers, the fuse, and all the accessories working together to provide the needed load that is required for the end user. So whatever references we make, we trace it back to the code compliances. And as we shared already, most of these code requirements are lifted into your specifications side of your electrical drawings, right? So now let's go on to those grounding and the bonding system that we have, right? It is very crucial electrical safety practices that is what used together to protect the equipment and the whole occupants in the facility, right? Let's look at the term here, working together is very important. You may have a grounding or bonding system in your wiring process. But if it is not working in alignment with all other systems, like your cables, your circuit, your fuse, then you don't have any insulation. So in order to get it work in alliance or together with all the other electrical system, you need to refer to your NEC, your National Electrical Code, or NFPA, which is the same thing, right? It defines the grounding system as connecting to the ground. So that is how this name is, connecting to the ground or a conductive body. What does that mean? We looked at early discussion about conduction, the bodies that reflect, conduct, and absorb. So think about what it is here, that your grounding system should connect not into any other than a body that is a conductive body or a ground, right? Conduct that electrical shock, force it to the ground, right? So, and that extended to the ground or earth. So most uh, crew on site, you may hear them referring to earth wire and also ground and so on and so forth. So they all refer to the ground. And so the earth wires that connect all those systems and then push it to the earth. That is what uh, the name earth wire, right? So let's define or pay attention to the bonding as well, right? So a bond, the code defined a bonding or bonded element as connected to and establish electrical continuity, right? So electrical continuity. So the bonding system connects to electrical wiring continuity and what is referred to as what conductivity, right? So it all boils down to your conductive body so that it provides that safety for your system. Right. So that is basically what that does mean. So grounding connect an electrical system to the earth, establishing a true pathway for fault current. Fault current here means excess current to flow safely into the ground. If we don't channel that to the ground and we allow those excess or overcurrent in the system, it will blow up and we may have the facility that we have get caught by fire and so on and so forth. So the part allow overcurrent protective devices like fuse or circuit breakers to kind of trip quickly, preventing damage or hazard to our facility. So that is importance of the grounding. Again, it also helps limit the voltages imposed by lightning. So when there's a lightning, heavy rain, lightning out there, this will help impose uh, limit the voltage that comes as a result of those lightning uh, or light line surge on our electrical lines, and then kind of in terms of the higher voltages. So that is why it is crucial to be able to make sure that your grounding and bonding system works very well with your entire electrical system. All right, talking about bonding will give you added advantages. All right, talking about connect all metal bodies or part of electrical system together. Metal bodies. That is why it's here. Establish electrical continuity and then conductivity here. So it connects all the electrical or metal parts of an electrical system together, ensuring they are at the same electrical potential, just a current, right? So prevent fluctuation of different body having a different voltages and so on. So this prevent the voltage differences that could cause shocks or damage to our system. So look at that little difference between the grounding and the bonding. Metal parts having the same voltages to avoid the shock and damage to our system. And then the bonding is particularly important in areas where you have static or constant electricity buildup, right? Think about that. So it links that to a flammable environment and help us to kind of identify how safe we can make our system be. All right. So when I talked about that briefly, can show it in pictures and all that. So the grounding will be found in section 250, uh, um, section A, article 250, section A talks about in the code talks about a typical installation of your grounding. It defined that as a typical electrical installation would require the electrician to connect the house wiring to earth, right? So this is a code requirement. You look at here, connecting electrical wiring to the earth. So pay attention when you're walking around your neighborhood, you may see things like that. It is the code compliant, which is found in your construction drawing, electrical drawing specification that deals with how to connect all your electrical wiring as a form of earth, right? This is done to limit, like I said, to limit voltage imposed by lightning and so on and so forth. I talked about that in the earlier slides, right? And then it prevents surge or surface arch, which is the lightning trips and all that. So very important. And you look at the chart here, you have your ground bus bar here, we have your natural bus bar, and then we have the hot wires, 120-volt hot wire. That we have hot wire here, and then we have the natural, and then you will have your grounding for the system as well. That's just very important. Now let's talk about the code a little bit. Everything, every references that we look at here goes back to the code because that is the mother of all, or the source of our construction specification when it comes to the electrical system. So the NEC talked about grounding wire requirement, right? So it's required to have all those grounding wires. Let me go back. Yeah, grounding to be a bare or naked wire to identify the earth or grounded wire. If it is insulated, right, it has to be green with yellow colored here. So when you go to get to any installation or installation of electrical system, you'll be able to identify your grounding or your earth wire as labeled bare, which is naked, or when insulated, it has to be defined by cable color like that, right? Aside from safety, grounding provides you a reference point for all for voltages, right? You have all the voltages, like you said, it has to be the same level to avoid surge or um, over uh, voltages as well, right? And then we talked to the bonding, essentially maintaining various exposed conductive body for your system. So that is important differences that we need to pay attention to, right? You look at the chart here. This symbol simply will define your earth wire. So the E is the earth wire, which is referred to your bonding. So it connects to the earth and can be in three locations. The location is clearly specified in the chart you see. So location one will be at the load end of your service drop. Service drop here, when you're from high voltage and stepping down to low, you can have one connection there that push every differences that may transition, which is over to the next phase. The excess of it force it to the ground. So here's we have one point here. And then you look at your bus bar inside your service equipment here, you can also create another bonding system here and all force it to this area. And then the last one will be when you have your in-service connections coming in here, you can create another bond here and force it here down to the rod that we have. So in your drawing, you'll see that symbol is simply referred to as your earth connections, and then you will trace that to the drawings where you have the E attached. Some of these lines here indicating that's a point where you have your bonding or earth wire connected to the system from transitioning into the ground to avoid any trip or overcurrent causing damages to your system. All right, so typical example here, right? This is an approved grounding wiring method. Let's see why it is approved, right? It's a smooth transition here. We have one rod with a ground rod electrode conductor, which is a conducting body that you can kind of attach your wires to, right? And then we have one here as well. You look at the transitioning from the cables or the wires. So non-metallic conduit having the process here, and then they all have a continuity. Yeah, so we talked about that earlier. There shouldn't be any sort of breakages or disconnect in this process. So that is really important. Let's understand why this is wrong method of wiring, right? We have a huge electrode, right? Ground electrode conductor connecting two bus, and then we have a rod forcing it here. So there could be a trigger here that allows discontinuity or breakages. So that is typically wrong for our system. There shouldn't be a direct connection of two electrodes and then one forcing it out. It should be through the wires, through the cables, right? That system, very important. All right. Again, when you watch the video, have questions, you know what to do. Just give me a short email as we do always. All right. All right. So we talked about the grounding electrodes. These are simply the rod or stick, as you can see here. So that fancy name is about that little rod that help us connect all our grounding system to enforce it to the ground, right, or to the earth. So they provide that electrical connection, like I said, to the ground and act as well to dissipate or spread the current to the ground, right? So that is exactly what your ground electrode does in helping your grounding work function properly within the entire electrical installation system, right? It can be a natural or made. What is natural? The natural is what intrinsic, which is part of the internal system, like you see over here, to the structure. This could be your metal underground water pipe or water piping. If you have this as your copper pipes for the water, you can just use it as an electrode, grounding electrode, connect that to enforce your system through. That's okay. You may have a metal framework somewhere as part of your structural system away from the building. You can connect to that, and then you can have your uh, reinforced concrete in your foundation. Because it's attached to the earth, you can still use that. So those are the natural stuff that are parts of your structure. So when I say natural, it's not nothing, anything from somewhere. It's part of your structural element in your construction. It can also serve, especially as it connects to the ground, it can still serve as your grounding electrode by connecting those earth wires to make it uh, work for you, right? Let's talk about what is made. Right. In terms of that, you can have a special buried metal plate somewhere and connect your system to, or mesh conductor somewhere else, or rod purposely used as your um, grounding electrode rod over a, a point, right? Think about ground rod. It can be a specific rod that is used uh, than the single. That is the most single use and efficient, effective grounding device in practice today. You can have a special rod. We will see it very soon. Bury it somewhere and connect all your um, earth wires too. All right. As we can, let's go back and see, yeah, stuff like that, right? As we saw from here, this is a typical rod system, right? And then you bury it close to the building and then connect all your earth wires too. That's the most commonly used. All right. Let's go on to where we are. All right. Looking at this point, there are a few alternatives here. So, if, um, for instance, different types of electrodes are present in the building, if these are all uh, can be used as a bundle together to form entire grounding system. All right, so we have these lists here, about seven of them, material types or different elements or component that can be used for your grounding system as well. Start from your plate electrode down to up to your metal underground water pipe, and so you can use a combination of these type as your for your grounding system. Very important, right? Again, looking at this point, we have seven types. That is, if none of these things we listed here or are listed here are not present, or you don't have it, you can go by one of these seven types in absence of those ground electrodes, right? For instance, you can use a bare copper ground ring and then rod and pipe electrodes and so on. So always there's an option to deal with. Again, it is important to understand or understand all your underground gas pipe system are not permitted for use as ground electrodes. Underground gas pipe system are not, because they can explode, because we are dealing with cable here. And then the section of the code that deals with that is 250 section 52 article B, bar you or prohibit any construction project to use a gas pipeline system as part of their ground electrodes to connect the earth. So look at it, think about the exceptions. Here we talked about if it is water pipes, it can be used, but the gas is prohibited or prevented. All right. So connection of grounding electrodes to the grounded conductor can be performed in three different ways, right? When you're doing or installing those grounding system, it can be done in three different ways. Those are the list here. Grounding electrodes conductor can run to individual from the ground conductor electron directly. So look at that here, right? Or that going here, connecting to the bodies that we talked about, right? So this is connecting to the rod, and then it can be to that structural element somewhere, and then it can be concrete reinforcement through the concrete. So this individual grounding electrode is allowed in the system. And then we can also have it uh, grounded, bonded jumpers that can be also accepted. You look at that, the service here, and then we have three options that bond these elements, right, together. So that's a typical wiring system when it comes to connecting your ground electrode to your um, bare wires for grounding and bonding work. Right. Typical scenario as you see here, right? You have your all your system, right? You have your service equipment right here. Within that service equipment, you can ground your system. So you see that connecting to bus bar here and right now grounding electrode all the way to that connection, which tie those, and this goes to the ground rod, and then this is a metal underground water pipes, and then you can connect that to the metal body. As we said, this is a structural column. It's part of your structural element of the project. You can connect that to the rod as well, and they're all hooked to your uh, connection made within 5 feet of the system right here. So that is typically how you can go about doing your grounding and the bonding system for your project. I hope this is making a bit sense to you. After you go through the video and pull the slides from the canvas, do that together, and then it will make more sense as you proceed, and it give you more idea to be able to complete the exercise. All right. So when you're connecting your rod to the ground, you need to check the stability of the ground as well, whether it's going to be able to act as a grounded area for your system. So you need to check the sensitivity rate of the soil. If not, you can kind of made it as well. So the important thing here is that based on the soil sensitivity, the design you can locate the area of most conductive. We are looking at conductive soil here, so that when you have the power getting to that ground, it can conduct it very well, right? So you can kind of made the ground by introducing what is referred to as composition. You kind of cement or any other additive mix with the soil to be able to hold as a conductive soil. Again, that is done looking at your construction schedule and making sure that that practice is cost effective uh, to go for. Right, the bonding are very important, right? Grounding and bonding work together. They work together as we've been described to safely give us that electrical system that we need, right? So bonding is essentially connecting and maintaining the various exposed conductive part, as I talked about that already substantially. It's the same potential, right? of the electrical connection. So expose metal part for your connection. So they connect all the accessible or metal work that are associated with your electrical installation. So to kind of help create a safe earthing system for your electrical stuff, right? Look at that here. The bonding will give you, these are all exposed electrical, oh, sorry, metal surfaces that need to be bonded properly with your cable so that they give us a good safety for your insulation. So uh, most of your metallic connection in the design may consist of water pipe, gas pipe, HVAC ducting, and so on. These are all exposed areas that need to be what bonded for your system. And then there are two aspects of what those bonding aspects. So main bonding, where we have the service entry of the building. And then we have the supplementary bonding within the rooms. So the main entrance, you have the bonding system, and then the rooms, particularly the kitchen areas and the bathroom where the places are wet, you have supplementary one to be able to protect your wiring system. Right. And then let's talk about a few components of effective grounding when you those components that we need to look at for in terms of grounding our electrical system, right? Very effective. Most important aspect is ensuring the lightning protection when there's lightning out there, it shouldn't get straight to your system. You should provide a pathway for lightning energy to safely flow to the earth. So when you're installing your bonding system, the idea should be creating a channel to be able to force lightning to safely get to the earth. Other than that, it may disrupt your system. If current if the current does deviate, there is four things that you need to look at here may cause these hazard for you. So the reason is to consult with your professionals or your electricians to be able to give you a system that will help protect in case there's a lightning and to avoid fire and all that trips. Right. Maintenance procedure, whatever system that you have, you should understand how you're going to maintain it. It's not about installation only. Maintenance is very important, right? So, whilst installing your electrical wiring system, you look out for a safe avenue to be able to maintain it, right? So, regular inspection is key. You need to check the rod for your grounding rod if it's still conductive enough to ensure tight connections. If not, you need to be replaced. If it corroded for up to some point, you need to replace it with a new one. Always need to do the testing after installation and have a maintenance schedule that will help you perform a ground resistant test periodically to ensure you meet the safety standard. The ground should be conductive enough to protect the system. So check the ground. If not, it may cause triggers for you. If the lightning and the forces and it couldn't hold as a conductive soil or sensitivity level is low, it may cause a problem. So you need to perform that regular resistant test and then enhance the soil. And then soil moisture management, ensure proper drainage to maintain low soil resistance and enhance effective grounded system, right? Corrosion prevention. When your system is corroded, use the corrosion resistant material for ground rods and also connection to prolong the lifespan. So these procedure will help you to maintain your system as long as you prefer. Very important. All right, I put a grounding and bonding demonstration here. This is in the slides. When you download it and go through it with this video, pay attention to the demonstration on the slides. It's about 3 minutes each. Uh, will give you a typical idea how this is captured on site when grounding and bonding are being conducted or installed together with all the electrical system on site. So that demonstration is in the slides on Canvas. Download it and it will help you understand what we're talking about so much. Right, so typical electrical grounding system layout, as you can see here. You see that pipe going all the way here. And then we have your electrical grid, that's Elton grid here connected to that pipe, and then to the high tension cables over here. So take a look, all grounds are those. These are earth rod, and then the soil with that metal frames as we saw. So that is how you bond all the system together to give you that safety. Right. All right. I hope this makes good sense after you pull the slides and watch all the demonstration. Like I said, with this video, you should be able to be good to go. Right. Let's look at lightning, briefly, lightning fixtures. Next week, when we are in class, we will look detail into lighting fixtures. No, not light, lighting fixtures. This is a brief introduction to what we're going to be doing next week when we meet in class. Right. So, lighting fixtures are found in, as we are doing, electrical division 26, and section 8 deals with everything lighting fixtures, right? You go to the subsections here, 26, 5100 deals with all types of lighting that are found in interior system or interior part of our building. And then safety lights will be under 52, section 00, subsection 00. And then that's also detail what are the safety light system that we have, and then the classification of location where lighting should be or light should be in our project are dealt with 54. So look at division 26, uh, section 8, 54 here to 56 deal with exterior lighting, special purpose lighting, and so on and so forth. So in the code or in our mostly in our electrical drawing specification that are picked from the NFPA or electrical code deals with this general stuff, right? Lighting fixtures, poles, parking lot lighting, requirement that needs to be followed in order to install some of this. We have safety lighting and fixture installation. How do we install those fixtures to meet the code compliance? And then power and ground and conductor termination and so on. So in general, the code deals with this list of what items as you see here. All right. So basically, we have types of light fixtures required depends on what several factors in your project. Whether which type of fixtures that you need will depend the type and the location in your project to be able to do those selections. So we talked about where those lights are installed, the costs, and the purpose for the lighting. For the light, what am I saying? Lighting continuous is lighting. All right. All right. So other consideration for uh, the aesthetics, the location, and those skill installers and suppliers or vendors close by will also make an impact based on your selection. Most light designers categorize lighting fixtures into three main types. We have the ambient, the task, and then the ancient. This also informs the selection of your light fixture, right? talked about the ambient light, we are saying brightness up the whole area. So if you're looking for light that bright, the whole uh, living room or the whole uh, floor space for your manufacturing, the whole office conference rooms, you'll be look at what constitute an ambient light, and that selection will be made based on the purpose for which you need the light for. Think about the task. Task here is the light that do specific tasks, hence the name, right? You can have a lamp, right? I don't know if I can show you. If you look at here, um, I have my lamp here that purposely shine or throw light to where I'm sitting to be able to do this. So that's the specific task light. I can turn it off when I don't need it because I'm not doing the video for you guys. Yeah. So your table desk light can be a task. And then the ancient light will deal with uh, uh, features where you need the light won't be bright enough, right? So it's a kind of a decoration. It's a kind of it's not for really a test or you want it to shine or everywhere. It's kind of decorative stuff, right? Display, you go to the art museum, you see those light, so they enhance the atmosphere of any room, right? To give you that beauty. All right, so light fixture or what is referred to as luminum. It's a technical professional term that goes with these guys here. Electrical fixtures used to hold those lamp or the bulb or the light source, right? So different type. We have a common lamp type, including incandescent, halogen, and so on. So five different, but mostly these days, in most projects, you will find your LED lights in those lighting schedule or fixtures in your project, which is light emitted diode, which is LED, commonly used lately. All right, and then we can talk about trophies. Those of you who did drawings too, you did a design where you have to select these different trophies, the sizes 2x2, 2x4, 2x6, 4x4 in your project. So all those are detected based on the project requirement found in your specs, right? So looking at the fixtures, you can have the T's, T12, you remember that? You have a T5 and so on, and they are all integrated or integral part of your LED sources, right? You can have a lay-in fixture or a recess, which is a little bit push uh, deep into your ceiling to have that recess and give it that level for you. Very important. We have a surface. So like I thought, this is a typical surface. It's just attached to the ceiling, as you can see here, right? Indoor light, very important. We talked about recess. I talked about recess. You see that goes in there deep into the ceiling and throw the light into these spaces. So it depends. How do you differentiate all this? You will find them in your project specification. It tells you the methods of installing these light and also the process of selection, right? And then you need to cross-check with the vendors and the manufacturers to be able to make this selection. And as usual, if there's any discrepancies, you will want to do your submittal with your owner's rep and make sure you have the right recess light and surface stuff and flashes that you need, how it flashes with this for your project to be able to do a good job and cross all your punch list, right? So we have different mounting methods, how the light is mounted over here. As you can see, you can have a high bay and then the low bay. The name is the differences here is that, guy, 20 feet or more will be high bay. And obviously, that may cost additional money compared to the low bay, right? And then the wide range of indoor lighting, as you can see here, these are high bay. It goes way more than 20 feet for that project. Warehouses, data centers, most theaters and all that have a high bay, more than 20 feet. That light needs to be installed over there. And these are things you need to look out for as a leader leading the electrical installation for your project. You should be able to identify the ways you will deal with all these differences. All right. So, like I said, the difference, anything lower than 20 feet will be low bay. And the most significant thing I can talk about here is cost aspect because you may need more crew to do high bay and spend more time to do it compared to the low bay mountain system, right? So basically that's it. All right. I have about four demonstration on light fixture installation in the slides that are on Canvas. So just take it's about 30 minutes or maximum 4 minutes each, average 2 to 4 minutes to watch one of them. Pay attention and just take a look at that whilst you go through this video. With that, we will conclude for this portion. Again, this is typically for Monday work. So go through that. The quiz is going to come from this. So after you go through the video, do the quiz. And then on Wednesday is our usual um, in-class exercise. All right. So I'm going to share this quickly for you. Let me go through that. Give me 1 second. Hmm. Okay, right here. Right here. Okay, so let me quickly share that. I'm not going to go through that long discussion. So this will be posted on the assignment session as usual, as we do it, all right? Go through it. Go through that, right? Make sure you have your group names, everything in there. Those of you who work together, and make sure there's going to be two drawings for you, your plan, view, and specification. So the drawing names are here. E004 for the entire electrical drawing that consists of feeders and all the services. And then you have the specification to this that picks some code requirement and define how this has to be done. I'm going to be posting it on the assignment session, so look out for that. And this is for Wednesday, and that covers the 2 days that we meet for the class. So this is a group work for you after you go through all the document. And this is going to come from things that we've done from the past 3 weeks up to now as well. So that is all that this is going to be for you. All right. Thank you so much for your time. I'll see you next week in person. All right. Thank you.